Hello, welcome to Learn with Lakineni. In this video, I am going to explain you about the 3D Numpy arrays. So, how you can create a three-dimensional Numpy array. So, what is the importance of three-dimensional Numpy array? So, as a data scientist, how we can see the three-dimensional array? What are the operations are linked with three-dimensional array? And how to slice the elements or values from the three-dimensional array as well as a two-dimensional array and one-dimensional array. Here in this video, I will explain both slicing operations in one-dimensional array, two-dimensional array, three-dimensional array, and also how to select a particular element in the three-dimensional array, two-dimensional array, and one-dimensional array, and how to select a set of elements randomly from the arrays will be explained. So please watch this video. Definitely you will enjoy and you will learn a new thing about NumPy, one-dimensional, two-dimensional, three-dimensional array. In later videos, I will also explain the various ways of creating the NumPy array. So you can create the NumPy arrays in different ways, not only with an array method. You can have so many methods are available in the NumPy. So with that arrays, with that methods, we can definitely create different types of NumPy arrays. Okay. So please watch this video and also please subscribe to my channel, Learn with Lakineni. What is a three-dimensional array? Actually, 3D array. What is a 3D array? A 3D array is not simply a 3D array. A 3D array is, what is a 3D array? 3D array. What is 3D array? A 3D array is nothing but a sequence or a set of two-dimensional arrays. Two-dimensional arrays. A 3D array is nothing but a set of two-dimensional arrays. Why I am saying this is, suppose if you want to create a three-dimensional array of size 3 by 4 by 2. That means we will call this as a three-dimensional array. But I will say that this is not a three-dimensional array. This is a sequence of two-dimensional array. That means this three-dimensional array can be represented in the form of a three two-dimensional arrays. Three two-dimensional arrays. In every two-dimensional, there are four one-dimensional arrays. In every two-dimensional array is a what? Actually, what is a two-dimensional array? A sequence of one-dimensional arrays. So here 4 indicates in two-dimensional there are 4 one-dimensional arrays. One-dimensional arrays. In each one-dimensional array there are 2 elements. There are 2 elements. That is the actual meaning of three-dimensional. Simply a three-dimensional array means a sequence of two-dimensional arrays. Suppose if I write 4, 2 by 3. So this is a three-dimensional. But how you will say it is a 4? It is a 4 two-dimensional arrays. Again it is a 2 one-dimensional arrays. Again in one-dimensional you have 3 elements present. So this is what about a three-dimensional array. So why I am saying a two-dimensional array is a sequence of a three-dimensional array is a sequence of two-dimensional array. If you keep 2 or 3 two-dimensional arrays side by side, it gives you a three-dimensional array. Suppose if you see, suppose here I am writing, here I am placing a two-dimensional array. Let us suppose this is a two-dimensional array which is consisting of 3 rows, and let us suppose this is 4 columns. Again I am placing the same size two-dimensional array beside this, behind this. So this is again of the same two-dimensional array like the previous one. Now if we join this, these two dimensions, then it gives you a 3D. What is a 3D? This is here. There are two dimensions. 2 by, what is size? 2 by. So in each 2 dimensions, how many 1 dimensions are there? 3 1 dimensions are there. In each 1 dimension, how many rows are there? Columns are there? 4. So this entire 3D array can be represented in the terms of 2, 3, 4. That means 2 by 2 dimensional arrays. In every 2 dimensional array, 3 1 dimensional arrays. And in every 1 dimensional, there are 4 elements. So this is the way of representing the 3-dimensional array. So this is the front face. This is the back face. This is the first one, 0th 2-dimensional array. This is the first 2D array. So in each every 2D array, you have several rows and columns. In this you have several rows and columns. So this is the way of representing a 2-dimensional array in the form of a sequence or a set of 2-dimensional arrays. Okay, I hope understand this. I hope all of you understand this geometrical representation of a 3-dimensional array. Now we will see how to create a 3-dimensional array and how you can apply different operations on the 3-dimensional array. Suppose in 3-dimensional array, what we have, suppose if you have 2 by 3 by 4, you want to create a 3-dimensional array of size 2 by 3 by 4. That means 2 2-dimensional arrays. So how you will create? So here I am creating, this is 1 dimension, this is 1 2-dimensional, here this is 1 2-dimensional. In each 2 dimension, how many 1-dimensional elements are there? 3 1-dimensionals are there. 1 2 3. So this becomes a 2-dimensional array. Here again 1 2 and 3. Again this becomes another 2-dimensional array. If we keep these 2 dimensions, these two dimensions into another square brackets, then this indicates it is a 3-dimensional array. So in each 1-dimensional array, suppose let us suppose 4 elements are there. 1 2 3 4. Let us suppose 5 6 7 8 9 10 11 12. Here let us suppose 13 14 15 16 17 18 19 20 21 22 23 24. So now how you will create? With the method array. So what is the Numpy? NP dot array of these two-dimensional arrays will give you the 3-dimensional array. So this is the way of creating a 3-dimensional array using the code. So here I am just here, if you want to do any Numpy operation, you have to import Numpy as NP. Import Numpy as NP. So import Numpy as NP. Here I am creating a 3-dimensional array. A is equal to NP dot array. NP dot array. You just open. Suppose let us suppose I want to create a 2-dimensional array of size 2 by 3 by 4. That means 2 2-dimensional arrays. In every 2-dimensional, 3 1-dimensional arrays. Again in every 1-dimensional array, there are 4 elements. Okay. First of all, I will create. See here. So first square bracket. In every 2 dimension, how many 1 dimensions are there? 3 1 dimensions. So these are 3 1 dimensions. Again, I will put these 3 1 dimensions into a square bracket. So it becomes a 2-dimensional array. Like that, I am creating another 2-dimensional array. Again, I will put these 2 in 2-dimensional array. Again, finally, I will keep all these into final square brackets. It becomes a 3-dimensional array. So, for the flexible understanding, you can put, so here you can keep like this. So here this is a two-dimensional array and this is a two-dimensional array. Now I will insert the elements into the array. In every two dimension, how many rows are there? 3 rows. 1, 2, 3. In this, 1, 2, 3. Now I will insert in every row, I will insert 4 elements. Okay. So let us suppose 4 elements. 1, 2, 3, 4. Okay. 5, 6, 7, 8. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Here 21, 22, 23, 24. So here like this I have inserted the elements into the array. Now I want to print A. So the three-dimensional array is successfully created. So this is a three-dimensional array. So here this is one two-dimensional array. This is one two-dimensional array. As I already explained that a three-dimensional array is a sequence of two-dimensional arrays. So this is a way of creating a three-dimensional array in Numpy. Okay. If you want to see the type of a values of values which you have inserted into the array a dot d type. So all the elements are of type integer 32. Okay, if you want to see the number of elements in the array, in the three-dimensional array is 2 into 3 into 4. That means 24 elements are there. So if you want to see a dot size, it gives the size as 24. Suppose if you want to, all these elements are by default integer type. Suppose if you want in float type, you just type here d dot d type is equal to within quotations float 64. Now if you run this, so you can see all the elements in the array are in the form of float. That means all are converted into a float type. Suppose if you see a dot d type, so it is showing that the elements are of type float. Here it is saying the elements are of type float. Okay. So this is a way of creating the three-dimensional Numpy array. Suppose for fun, if you give the element, suppose if you write like this, d type is equal to bool. If you give d type is equal to bool, and if you execute, all the elements are converted into true, because you want to print the element in terms of a boolean type. So when it will be printed in the boolean type, all non-zero numbers will be treated as a true, 0 will be treated as false. So here in the given array, by default basically all the elements are of type integer only, and they are non-zero numbers, so that every element is represented in terms of a true. So this is called as boolean array. Suppose if you write d type, if you want to see the actual value, then the type of the elements in the given array is boolean. Okay, so this is the way you can convert the elements into the boolean array. So okay, now I will explain how to slice the elements from the three-dimensional array, how to retrieve a sequence of elements in a particular fashion with a particular logic from the three-dimensional array. Okay, so now we will see the geometrical representation. Suppose I have a three-dimensional array. Here I have a three-dimensional array. So this is a three-dimensional array. This is a three-dimensional array. Here you have another three-dimensional array. So this is a two-dimensional array. This is another two-dimensional array. This is another two-dimensional array. Here let us suppose there are elements 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let us suppose 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Now this is a three-dimensional array. So this is called, the first phase will be at index 0. This phase is called as zeroth indexed phase. This is called as first indexed two-dimensional. This is zeroth phase two-dimensional. So this is zeroth two-dimensional array. This is first indexed two-dimensional array. Suppose if you see, this is at index 0, this is at index, this is at index 1. So here if you see, we can represent the index both positive index, and also you can represent index in the form of a negative index. So if you take only the positive index, the index will be like this. Here this is at row 0, first 1, 2. This is at column 0, column 1, 2, 3. In the similar fashion, so this is at row 0, 0th row, first row and second row. So this is the 0th column, first column, second column and third column. So this is what is called as positive indexing. Suppose if you want the element at this position, so first of all you have to say in which two dimension the element is. So this is the element at 0th two dimension. That means it is at 0th two dimension. Okay. So in 0th two dimension, in which row it is? It is there at third. It is there at 0th location. Okay, 0th row. In 0th row, in which row it is? In which column it is there? It is at column 2. So this is the way of representing the index of a particular element. Suppose if you want this element index, so this element in this is the element in which indexed two dimension. So this is the element at a first indexed two dimension. So in which row it is? It is there at first row. In which column it is? It is there at column 2. So if you write, if you row this, then the element 9 will be printed. That means if you want to reach the element 9, you have to write this index. If you want the element 3, you have to write this indexing. Okay. So first of all, this is two-dimensional index. In the two-dimensional index, what is the row index? In that, what is the column index? Okay. So this is the way of getting or retrieving a single element from the three-dimensional array. Okay. So we will see the same thing in code. Here, let us suppose I have created a three-dimensional array of size 2 by 3 by 4. Now I want to print this element. I want to print this element. So if you want to print this element, so what is the location? This is 0th two-dimensional array. This is first two-dimensional array. In this, in which place it is? This is in the first row and second column. That means 0, 1, 2. So if you print 0, 1, 2, this you can print the the value of 7. Okay, you can see here. Suppose print A, open the square brackets, and that you mention it is a 0th index and first row, and it is in the second column. Then if you press it, so what is printed? Element 7 is printed. Okay, so this is a way of retrieving a particular element from the given 3-dimensional array. Suppose if you want to print, suppose if you write A square brackets first 1th 2-dimensional array, in that some row 2, in that I want the third column element. So it is printing 24. That means it is printing this 24. This is in first 2-dimensional array. In that, this is in second row. In the second row, it is in third column. So that's why 1, 2, 3. So it is giving the element as 24. Okay. Similarly, you can use negative indexing also. Here I have mentioned the negative indexing. So the negative indexing starts from here in the last row. The negative indexing will be -1, -2, -3. Here -1, -2, -3, -4. So this is the 2-dimensional array at index -1. This is the 2-dimensional array at index -2. Now you can apply the negative indexing in order to retrieve the elements from the 2-dimensional array. Okay. So suppose if you want to print this element, you can print in multiple ways. You can use the positive indexing, you can use purely the negative indexing, and you can use the combination of positive and negative index. Suppose if you want this element to be printed, so this is at which one 2-dimensional array, 0th 2-dimensional array. This is positive indexing. And if you want to represent the row number with the negative indexing, this is the row at index -2. That means -2, comma. So in which column it is? If you go with positive side, this is at column 3. If you go to the negative side, it is column at -1. So if you use this 0, -2, 1, it gives the element 8. Suppose if you want all the all the indices to be shall be negative, then you can represent with the negative. So this is the 8 at which negative indexing 2-dimensional array? -2. So -2, comma. In which row, negative row it is? -2, comma, and -3, -1. Now it gives the element 8. That means you can have any combinations, either pure positive indexing or pure negative indexing, or combination of positive and negative indexing. Suppose if you want to represent this element 23, if you go with positive indexing, this is at first 2-dimensional array. In that, this is at row second row and column second. If you want to represent it in terms of negative, so this is at -1, this is at minus this indexing, and what is the row here? -1, -2, -3. So it is at row -1, and in which column it is? This is -1, -2, -3, -4. It is at column -2. Suppose if you write -1, -1, -2, then also you will get the value of 23. So this is a way you can use both negative indexing and positive indexing in order to retrieve a particular element from the given 3-dimensional array. Suppose here I have used the indexing array -1, -2, and 3. So after executing this, what is the element I got? I got the element 20 as the output. So -1, -2, -3. So why Here I want to print the element at -1 2D indexing, -2 and 3. So this is the two-dimensional array. The index is, the negative index is -1. So this is the two-dimensional array. The negative indexing is -2. So -1 means this will be selected. This will be selected initially. In that, what, in which row you want? -2. That means this is -1, this is -2, this is -3. This row you want. This row you want. In this, which column you want? Here I mentioned the positive column number. So 1, 2, 3. So this element will be displayed. That means, so after printing, you will get 20 from the given array. So this is the way of using the positive indexing and negative indexing, or combination of both positive and negative indexing, in order to retrieve a particular element from the given array. Okay. Another way of printing the required element from the array is, you can use like this also. So suppose you can mention separate square brackets for each index. Suppose here I have used -1. Again I have used again separate square brackets. Again I have used separate square brackets to include 3. Suppose if you write in the same manner also, you can get the value of 20. That means you can keep the indexing within a single square bracket separated by comma, or you can use the index for each dimension separately with the square brackets. Here I have mentioned -1, here I have mentioned -2, here I have mentioned 3. Suppose on you are applying this operation on the given array, Numpy array A. So it gives the output as 20. So both notations can be used. Here I have separated with a comma, -1, -2, 3. This also prints 20, or this also prints 20. So both ways are valid, both ways can be used. Okay. Suppose if you want a random elements from the given three-dimensional array. Suppose I want this element, I want this element, and I want this element. So here you cannot apply the slicing operation. Why? Because there is no pattern to slice from the given three-dimensional array. So you are randomly selecting some elements from the array. So in such case, how you can retrieve the elements randomly from the given array? Means you have to use advanced indexing. You have to use advanced indexing. Here simply, what are the number of elements you want, you simply mention the elements locations and you retrieve the elements from the given array. Suppose here 6 you want. So in which two-dimensional array it is? It is at location 0th two dimension. Okay. And what is the next one? So this is the 12 you want. So 12 is at which location? It is at 0th two-dimensional array. Okay. So next element is 16. 16 is in which two-dimensional array? It is at first two-dimensional array. So here I have mentioned the 2D indices. The 2D indices. Again, suppose when you come here, in which row it is? It is at row 1. Okay. Right. All the rows you write at one place. When you want to retrieve the element 12, in which row it is? It is at row 2. And when you want to retrieve the element 16, in which row it is? It is at 0th row. Okay. This is row indices. Row indices. Here column indices. In which column it is? It is at column. If you write positive direction, it is column at 1. In which column it is there? It is there at column 3. In which column the element? What is the index of this element? At 0, 1, 2, 3. 3. Okay. So if you print in this manner, you can retrieve the elements at your required location. That means here the elements will be paired up. 1, this 0, 1, 1. 0, 1, 1 means 0, 1, 1. So what is the element at 0, 1, 1? At 0th index, 2D index, at first row, at first column, 6 is there. So it prints 6. In the similar fashion, 0, 2, and 3. So 0th two-dimensional array in the second row, in the third column. So what is this? 0, 2, 3. It gives which element? 12. So again 1, 0, 3. In the first two-dimensional array, that means 1th index two-dimensional array, at location 0th row, at location third column, what the element is there? 1, 0, 3. The element at this location is 16. 16 will be printed. So this is the way of selecting some random elements from the given array. Okay, we will see the program. Here you have to write A, open the square brackets, again open one square bracket for two-dimensional indices, and the square bracket for row indices, and the square bracket from column indices. Again you just write, suppose 0, 1, 1. Here all the indices are, suppose 0, 0, 1. Here that is two-dimensional row indexing. Here some 0, 2, some 0. Here I am writing the column indices. Column indices 1, 3, 3. So here this one is 2D indices. This one is row indices. This one is column indices. Okay. Suppose if you execute this, see the output. So you have retrieved the required elements. So this is the at location 0, 0, 1, the element 2 is there. At location 0, 2, 3, 12 is there. At location 1, 0, at location 1, 0, 3, the element 16 is there. So this is the way of selecting your required elements from the three-dimensional array. Similarly, which you can apply on the two-dimensional array. Similarly, which you can apply on the one-dimensional array. Suppose if you take a two-dimensional array, this is very simple. A two-dimensional array is nothing but a set of one-dimensional arrays. Suppose if you take a two-dimensional array, let us suppose here the elements are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, some 20. So here if you take the positive indexing, this is 0, 1, 2, 3, 0, 1, 2, 3, 4. Suppose if I want the elements at location, this element I want, this element I want, this element I want. So there is no specific order to slice. So here what you have to write? Simply you have to write A, open square brackets, in that you mention the row index, in that you mention the column index. So this is the element at index 0. This is the element at index 1. So this is the element at index 3. So this is row indexing, row indices. Okay, suppose if we come here, so this is the element at column 1. This is the element at column index 3. This is the element at column index 3. So now if you print this, here you will get 2, 9, 19. These elements will be displayed. Here this one, this row and this column will be paired. This row and this column will be paired. This row and this column will be paired, so that you will get this information. Okay. So this is the way of retrieving the elements from the two-dimensional array. Suppose if you write, if you want to create two-dimensional array, you can create the two-dimensional array. Suppose let us B is equal to np dot array of, here I want to create two-dimensional array. Here I am taking 1, 2, 3, 4. Here I am taking 5, 6, 7, 8, 9, 10, 11, 12. Suppose if we execute this, this is the two-dimensional array. Suppose if we want to print the element this one and this one, so you have to mention first the row indices and later you have to mention the column indices. How you will write? Array, right, square brackets, again you open 2 square brackets, one is for row indexing and there is for column indexing. So this is at the element at 0th row, this is the first row, this is the second row, this is the first column, second column and first column. So this is the way of printing the elements. Okay. Suppose if you write A, again square brackets, comma, again square brackets. The first one is for row, so 0, 1, 2. Here when it comes to 1, 2, 1. Now you just execute it. Here what it is showing? Here the variable is not A, the variable is B. So now you got the required elements from the given array. So here this is the required element 2, 7, 10. Okay. So this is a way of selecting your required elements from the given array by using row indexing, column indexing. If it is 3-dimensional, you have to use the 2-dimensional indices also. Okay. In 2-dimensional also, you can have the negative indexing. Suppose negative indexing starts from -1, -2, -3, -4. The column starts from -1, -2, -3, -4, -5. Suppose if you want this element, you can write in many ways. Let us suppose this is an array A. You can write in multiple ways. A. So this is with positive 2 and positive 2. Positive indexing. Suppose if you take negative indexing, this is at -2 and this is at -3. If you take one positive, one negative, this is 2 and the negative is -3. Suppose if you take the first one is negative, this is -2 and this is 2. So in any of the cases, you will get 13 as a output. In any of the cases, you will get the output as 13. That means there are multiple ways of representing retrieving the element from the given array, either by using positive indexing or negative indexing or combination of both positive and negative indexing. Okay. Suppose if you want this row and this row from the array, you want the first row, 0th indexed row and second row. You want these 2 rows from the given array. Now you have to apply the slicing. So how you will apply the slicing? So A, if let us suppose if the array name is A, then here you have to write the row slicing and comma followed by column slicing. You have to write the column slicing. Here what is the row? Here you want 0th row and second row. So here I am writing, and every alternative column you want this column and this column. So from 0 to what is the last row? The row number is 3 colon step operator is 2. That means 0 to 2. It indicates 0 to n minus 1, 3 minus 1, 2. So 0 to 2. See every alternate value. 0 to 2, what is every alternate value? First one is 0th indexing, next one is second indexing. So when it comes to you want all the values in these two rows. So that means you can simply put colon colon. That means by default the begin starts from 0. By default it ends with last column. Here you have not mentioned any step operator. By default the step operator is 1. So this is one way of selecting the elements from the slicing the elements from the given array. You can write like this also. Suppose here I am writing A. Here I want from 0 to last every alternate value. So begin to here I am not mentioning any end. I am mentioning the step operator 2. So this is row slicing. In that row I want from 0 to end every value. So 0 colon, here I am not mentioning the end. If you don't mention the end, by default end will be the last column, and here I am mentioning the step operator is 1. So this is another way of writing the slicing operation. Okay, slice means when you want to apply the slice, the element should be in some order, some pattern, so that definitely you can apply the slicing operation. Suppose if you take the two-dimensional array, I want this element, this element, this element, and this element. That means I want the elements in the 0th row and I want the elements in the second row. In that row, I want only the elements at 0th column and the elements at second column. So like that I want to slice. So how you will slice? So let us suppose this is the array B. In that, row slicing followed by column slicing. What is the row slicing? From begin. If the begin starts from 0, you are not required to write 0. So 0 to the end. I want every alternative row. So this is the first row and this is the next alternative row. Again in the column from first to last, from begin to end, I want every alternative row. So that means 2. And also you can write like this also. 0 to end. The step operator is 2. 0 to end. The step operator is 2. Or you can mention with complete. I don't mention any begin. So that means the default begin is 0. So if I mention 3, begin to 3 minus 1. That means 0 to 2. Every alternative value, every alternative row I want. So in similar fashion, I don't mention anything. Here I will mention 4. That means 0 to 3. So this is also gives the slicing operation. Now we will do practically. B colon 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 2. That means comma. This is a row slicing. Now again colon colon 2. Okay. Then print. So have you seen the answer? Here you want the row 1, 2, 9, 11. So here 1, 3, 9, 11 is printed. Okay. Suppose similarly you can write like this also. B 0 colon colon 2. The step operator is 2. That means it is a row indexing which starts from 0 and 0 colon colon 2. In this case also you will get the same answer. Again you can write B colon begin. By default the begin is 0 to end colon the step operator is 2 comma colon 4 colon 2. So in this case also you got the same answer. That means you can write the slicing in different ways, but if you want to apply the slicing, the element should be in some particular fashion, then only you can apply the slicing. Okay. Suppose if you want to apply the slicing operation on the 3-dimensional array, suppose I want this row here I want this entire row I want to print and this entire row I want to print. In the similar fashion, in this entire row I want to print and this entire row I want to print. And that means I want the two consecutive 2D arrays. So here I want to print, here I want to print. First of all, I have to select the two two-dimensional arrays. In the two two-dimensional arrays, I have to select the alternate rows, this one and this one. In that alternate rows, I want all the elements. That means here you need three slicings. One is for two-dimensional slicing, another is for row slicing, another is for column slicing. So how you will do? So here, let us suppose the array is A. In that you have to write two-dimensional indexing, in that row indexing, in that column indexing. How many dimensions I want? From first to last I want all the dimensions. So I will write like this: colon, colon. That means from begin to end. This two dimensional I want, this two dimensional I want. So I have written comma. In every two dimension, which rows you want? I want the first row and the last row. That means alternate rows. So colon, colon, 2. Out of that, which rows you want? Which columns you want? I want all the columns. You just simply put colon, colon. Then you get the required elements. Okay. So another way is you can mention the indexing 0 to 2. That means 0 to n minus 1, 0 to 1. Every index, in every two-dimensional array, in every two-dimensional array, from 0 to 3, 0 to 3 means 0 to 3 minus 1, n minus 1, 0 to 2. I want every alternate row. In every alternate row, I want all the columns. So 0 to 4, colon 1. If you write this way or this way, you will get the same answer. Okay. So we will see practically. Suppose in this three-dimensional array, I want this row and this row, this row and this row. I want to slice and I want all the rows. So how you will write? This is a array A in which what are the rows you want? You want all the rows, colon, colon, comma. In each two-dimensional array, what are the rows you want? You want colon, colon, comma, every alternate one, and colon, colon, every value you want. From all the rows, you want all the column values. Or you can mention 0 colon, 3 colon. Okay, wait. Here, I want 0 colon, 2 colon, 2 colon 1. That means from 0 two-dimensional index to 2 minus 1, first two-dimensional array, I want all the elements. The step operator is 1. From in every two-dimensional array, I want 0 to 3 colon 2. That means 0 to 2, or the step operator is 2. Columns from 0 to 4, I want all the columns. In this way also you can write. Okay. Suppose if you don't mention the begin index, then also you can write colon 2 colon 1. I don't mention any begin index. Colon 3 colon 2, colon 4 colon 1. In any of the way you can write the slicing operation. Okay, now we will see practically. A colon colon comma colon colon 2 comma colon colon. Then you got the required elements. Okay. Suppose you can write like this also. A 0 colon 2 colon 1 comma 0 colon 3 colon 2 comma 0 colon 4 colon 1. In this case also you got the same answer. Okay. Suppose if you write the third one, colon 2 colon 1 comma colon 3 colon 2 comma colon 4 colon 1. In this case also you got the same answer. So there are the different ways of selecting the required pattern of slicing from the given three-dimensional array. I hope in this entire video you have understand what is a two-dimensional array, what is a three-dimensional array, how to take the random elements from the two-dimensional array or the three-dimensional array, or how to slice a particular elements from the two-dimensional array and three-dimensional array. I think this video will be more informative to understand one-dimensional, two-dimensional, three-dimensionals. Okay. Thank you all for watching this video. Please subscribe to my YouTube channel Learn with Lakineni so that you will get more updates on machine learning, deep learning, natural language processing tools and Python libraries. Every day we will update more videos, and in future we will go with competitive programming also. We'll solve some lead code problems and we'll keep update those videos onto the YouTube channel. Okay, so this video is completely for two-dimensional, three-dimensional array creation and slicing operations and advanced indexing and both positive indexing and negative indexing. We have explained this video. Okay, so please subscribe to our YouTube channel Learn with Lakineni. Similarly, another video will be posted on different ways of creating the Numpy array in the next video. Thank you, Vanda.